Copepods, are they the insects of the sea? I think firstly we need to understand the comparison that we're making. Both of these groups are arthropods, and they're both very old. Insects likely evolved in the Ordovician period, or some microfossils, but copepods is evolving all the way back in the Cambrian. Although more likely estimates would say they evolved in the Carboniferous or maybe the Permian period. The term insects of the sea isn't just describing the physiological similarities between the two groups. We know insects as one of the most successful taxonomic groups to ever evolve on Earth. The scientist, J.B.S. Haldane, famously said, "It would appear that God has an inordinate fondness for stars and beetles," in reference to the multitudes of both. It's also difficult to overstate the ecological role of insects terrestrially, and so today I'll be talking about the breadth of evolutionary radiation and the trophic importance of both of these groups. Which of these two do you think is a copepod? Trick question, they both are. What about these two? This one's a copepod, and so is this one. Even this guy's a copepod. There are over 12,000 species of copepod, and that is a lot, but compared to the 1 million species of insect, it's minuscule. The point of all of these images is to show you that while the total number of species of copepod is just a fraction of that of insects, the diversity in life history is still truly remarkable. All of these guys are copepods. Some are free-living planktonic species, some are benthic, living between grains of sand, some live in ponds or in leaf litter on forest floors, or up in rainforest canopies or at hydrothermal vents. Many of these species are parasitic, living within or on a host organism. Many of these species are microscopic, while some parasitic species can grow up to 20 centimeters long. The variety in form is comparable to that of insects, but the wide range in habitats is much more impressive in copepods. Copepods exist in almost every environment where there is water on Earth. They're the single most numerous group by individual, with planktonic copepods alone accounting for 46.8 billion tons of biomass. In his excellent paper, Entomology for the Copepodologist, Horst Schmidt said, talking about insects, "Entomologists are convinced that no other animal group can show such an infinite variety of feeding structures. They do not know copepods." And he's right. As you can clearly see, the diversity and complexity of copepod feeding structures is second to none. Let's start with insects. Incredibly, the evolution of a mammal into a species that eats specifically ants or termites has happened at least 12 times. It is so common for an animal to eat almost exclusively insects that the term insectivorous should be common to any biological scientist. Birds eat insects, mammals eat insects, amphibians eat insects, reptiles, fish, other arthropods all eat insects, and humans eat insects too. They are a key group in almost every terrestrial food web. Now let's focus on planktonic copepods. Marine food webs are generally size-structured, with microscopic phytoplankton dominating the primary production in most of the world's oceans. Zooplankton that feed on them lead directly to planktonovorous whales and fish, as well as the myroplanktonic larvae of many other species. In some of the world's oceans, copepods can dominate by up to 95% by biomass. When they're this dominant, they do not act just as a key group in the marine food web, but essentially as an entire trophic level, all by themselves. When it comes to the sheer diversity in life history, the role in upwards energy transfer, and the wide range in habitats, I think it's definitely safe to call copepods the insects of the sea. What they lack in the number of species, I think they more than make up for on the number of individuals and the diversity of their habitats.